Exercise 8.4, problem 21 to 22, solution. Curved surface area of a solid sphere is 24 cm square. If the sphere is divided into two hemispheres, then the total surface area of one of the hemisphere is, they given us few options. Curved surface area of the solid hemisphere. So that is basically 4 pi r square. So 4 pi r square is 24. And they say they are dividing it into two hemispheres, and they are asking us to find the total surface area of one of the hemispheres, right? So what is the total surface area of hemisphere? It will be 3 pi r square. Okay, so curved surface area is 4 pi r square, and that is equal to 24, which is given in the problem, right? So from which we can find the value of pi r squared. So pi r square will be 24 by 4, that is 6. I'm not finding radius because we will be using pi r square in the hemisphere. Okay, so TSA is 3 pi r square. Okay, when we cut it into two, the radius is kept the same. Please understand, you are not dividing. When you cut the sphere into two, the radius will not become half. It will become two hemispheres, and the radius of the hemisphere is still the same. Okay, so that is why we can use this way. Okay, so the hemisphere, the total surface area of the hemisphere is 3 pi r square. So that will be 3 into pi r square is given as 6. So we substitute that 6 here, it will become 18 centimeter square. Okay, so I hope you are, so this is, if let's say this is hemisphere, you are cutting it into two. So the radius is the same. It's the same number. Okay, so that is why we can use the same pi r square value. Okay, only thing is that since they are asking hemisphere total surface area, it will become 3 because that top area also needs to be calculated. Right, next problem, problem 22. Two right circular cones have equal radii. Okay, if their slant heights are in the ratio of 4:3, and then the respective curved surface area are in the ratio. Okay, so you got to be working out using ratios here. Okay, no problem. Let radius be r because both are the same radius, and let the heights be 4l and 3l. Okay, then you have to substitute them in the formula. Let the slant height of the two cones be 4l and 3l, and r be the radius. Slant height of the cone is pi rl. So CSA, curved surface area of the first cone divided by curved surface area of the second cone will be pi r into slant height of the first cone. Slant height of the first cone is 4l. Okay, divided by curved surface area of the second cone is pi r into l. The L is nothing but the slant height of the second cone, which is 3L. So substitute that here. So then this will become, this pi and pi will cancel, and R will cancel. This L and L will cancel. So you'll get 4 by 3. So curved surface area CSA1 by CSA2 will be 4 by 3. Okay. So the ratio will be 4:3. And that is option C. So I hope it's clear. If not, please go through this one more time. It will become clear. Thanks for watching this video.